Now we're going to look at the area, surface area and volumes of a prism. How do we work out the surface area and volume of a prism? Well, we use the same formula that we keep on using. The volume is the area of the base multiplied by the length, or the perpendicular height. And we will call... So what would we calculate the area of the base in this particular case? Well, imagine that this prism is standing on the table. The area of the base would be the area of this triangle here. And we know that the area of the base, the area of the triangle, is the length multiplied by the perpendicular height with inside the triangle divided by 2. Okay, the area of this base is 6 centimeters. The perpendicular height of this triangle, you can see I've sketched it in here, drop down a perpendicular from this point up here to the point where it meets at 90 degrees, the bottom of this edge. And that is 4 centimeters. And we're dividing everything by 2 because it's a triangle, it's half of a rectangle. So we get, that's the same as 6 centimeters. 4 divided by 2 is 2 centimeters. So we get equals 12 centimeters squared. So we now know what our base area is. And if this prism is lying down on the floor, what is the height then of our whole prism? Well, the height would be the whole length of our prism, which we can see is 10 centimeters. So the volume of our prism would be our base area times the height, the length of the prism, which is 12 centimeters squared multiplied by 10 centimeters. 12 times 10 is 120. Centimeters squared times centimeters is centimeters cubed. So the volume of this prism is 120 centimeters cubed. How would we then work out the surface area? Well, we've already worked out one of the surfaces. It's this triangular area here at the front. And we can see that this triangular area at the back here is going to have exactly the same area as the area at the front, because we've got a triangle at the front and we have a triangle at the back. If we look here, here's a similar prism to that one, and we can see that we have a face here at the front and a face here at the back that are identical. We've worked out the area of this face, so the area of both faces would be 12 centimeters squared plus 12 centimeters squared. So surface area equals the area of the base of the triangle times 2 plus 3 times the area of the rectangles in the prism. What do I mean by that? Well, if we have a look here, we actually have 3 rectangular shapes around our prism. One rectangle here, one here, and one here. We can take them out from this shape and just have a little look at it. Here we have our 2 triangular front face and back face, and here in the middle we have our 3 rectangular shapes that are helping us to form our prism. So they're the ones we have to work out. We can see that one rectangular shape will be the length of the prism itself multiplied by this length here. The one that's noted as 5 centimeters is the length of the edge of the triangle here. Not the vertical height, the actual length if you measure it with a ruler. So the area of one of the rectangles will be the length times the base, which will be 10 centimeters times 5 centimeters, and we will have 3 of those. And the area of the base times 2 will be 12 times 2. So we will have the triangular area will be 24 centimeters squared, 12 times 2, and 10 times 5 would be 50. 3 times 50 is 150 centimeters squared. So the surface area of the whole of this prism would be the front 2 faces plus the rectangles, 174 centimeters squared. Surface area of prism. So we have to differentiate between a volume, which you can actually think of as we're just filling this shape with milliliters of water and wondering how many centimeters cubed or milliliters of water we get on the inside of this shape. Whereas the surface area would be, if I was going to wrap this shape in wrapping paper, how many square centimeters of paper would I need to wrap it? Or if I was to spread it out and actually count how many centimeters squared I have in this shape, what sort of shapes do I have? 2 small triangles and 3 rectangles in this prism. And that's how I calculate volumes and surface areas for a prism.